while doing quantitative risk analysis, we spoke about expected monetary value analysis. In PMBOK, we have a diagram talking about a decision tree example. Many of you may find this diagram confusing because I keep getting queries related to this particular diagram. So in this video, we will look at how this decision tree and expected monetary value for each decision path has been calculated in this particular PMBOK example. Now this example talks about a problem, a decision where you need to make related to building a plant or upgrading it. So you are at a stage where you need to decide, do you want to build a plant or upgrade it? So we have to make a decision which is build or upgrade. Now in decision tree diagram, we have a node called decision node. Means this small square represent the path, one of the paths will be taken. So there could be two possible paths or two possible decisions. You say, I will upgrade it. The other possible path is, I want to build it. Now, these are the decision nodes. After decisions, there is a chance node. So what will happen if you upgrade? So there is a chance that you may have a strong demand. Like market is favorable and you may see a strong demand in the coming time. And the other possibility is you may get a weak demand. The same chances are applicable for both the conditions. Then you may have a strong demand and you may have a weak demand. Now let us look at the numbers which are given in PMBOK. It is saying that to build a new plant, you need to invest 120 million. This is an investment needed. To upgrade a plant, you need an investment of 50 million. It says the probability of a strong demand is 60%. So both these cases, 60%, 60%. And probability of weak demand is 40%, 40%. And it says that if you build a new plant and you get a strong demand, you can make a sale of 200 million. So here we can make a sale of 200 million if we build a plant because we have a more capacity and strong demand comes, we can serve the demand and we can make 200 million. If the demand is weak, we may only sell for 90 million. In the other option, since we are upgrading the plant, with an upgrade, we can get 120 million from a strong demand and we get 60 million from a weak demand. Now these numbers are representing building the plant, having strong demand makes you a 200 million. Now the next thing which we need to do is we need to identify that we say this is a path ending and we need to identify a path value, net path value. So net path value for this path would be 120 which you have invested minus in a minus format and the plus is 200 million and 80 million becomes a net path. So if you build a plant and there is a strong demand, in net you will earn 80 million in that particular decision. The second path value is you build, you spend 120 million, you earn 90 million. Your net path value in this case would be minus 120 plus 90 is equal to minus 30 million. Let us take the other paths. We identify a net path value for them as well. 50 million invested for upgrading it, earned 120 million. So minus 50 plus 120 is equal to 70 million. Spent 50 million, earned 60 million, minus 50 plus 60 is equal to 10 million. So now we have a path value of 80 million, 30 million for the decision related to building the plant. For upgrade, we have a path value of 70 million and 10 million. So what is the expected monetary value for build decision? What we need to do is multiply the probability. So we have a 60% chance of earning 80 million. So we say 0.6 multiplied by 80. We have a 40% chance of losing 30 million minus 30. If you multiply 0.6 with 80, we get 48 minus 0.4 multiplied by 30, we get 12. So the expected monetary value at this decision is 36 million. Let us take the second example. Here the expected monetary value is we have a 60% probability of earning 70 million. So we says 0.6 multiplied by 70 plus we have a 40% probability of earning 10 million. 0.40 multiplied by 10. So we get 4 million from this and we get 42 million here. So the total is 46 million. So that is what recommended here is that we have two decision options. Decision 1 is having expected monetary value of 36 million. Decision 2 is having expected monetary value of 46 million. So by this we can take maximum of expected monetary value decision and we can go for upgrade since it is giving us 46 million. Now this is how the tree diagram and expected monetary value both can put together and help us making decision on the basis of numbers.